lesson 104. This one is on semicircles, arcs, and then sectors. Okay, let's talk about what a semicircle is. Okay, first of all, I have a circle. A semicircle means half of a circle, just letting you know. Okay, so that's good to write down, is that a semicircle means half of a circle. Now, before I move on, let's review a few things. Do you remember what the distance around a circle is? What that's called?
Circumference.
Very good. Circumference. That's the distance around. Now, do you know what the formula for circumference is?
Pi.
Pi times d, diameter.
Yeah.
Okay? Now, let's also talk about area. Okay? The area is what part of the circle? The inside. So, area equals pi r squared. Do you remember those formulas?
Yes.
Okay, they're definitely good to write down and keep remembering because this will be on ACT tests and stuff like that. Okay, so you'll need to know these. Now, if the circumference of a circle is pi times diameter, what do you think the circumference of half a circle is?
Pi radius?
Kind of, that might make sense, but we're actually going to do pi times diameter and then just half it, divided by 2. Okay? That's probably the best way since we already know this formula. Okay? And then pi r squared is the inside of a circle,
Okay.
but if we are finding the area of a semicircle, then it would be what? Pi r squared
divided by 2.
divided by 2. Okay? See how we did that? Even if I took this same circle and divided it into 3 equal parts, and I asked you to find the area of one of the parts, guess what? You would divide it by 3. And the circumference by 3. Why? Because there's 3 parts. You see? So if we're doing half, we divide it by 2. If there's 3 parts, we divide it by 3. If there's 4 parts, then they've got to be even. If there's 4 parts, then you would divide it by 4. You see what I'm saying?
Yeah.
Okay, so that's kind of important to know. Now that we know that, they're asking me to find the perimeter of this figure. Now, what does perimeter mean? Do you remember what perimeter means?
Yeah, the distance around.
There's the distance around, so it's not the inside. Okay. And then they give me this. And
S.
4. 5, sorry.
Oh, sorry.
No. Some people probably thought that too. Okay, so, now, basically what we're doing, because we're finding the perimeter, we know that from here to here is 4. So then we know from here to here is 4. But what is this?
Well, if that's 5, then it's...
That is 5.
Yeah.
So, no matter where, actually this is the middle. From the middle, anywhere out, it's 5. So if this is 5 and this is 5, then this whole thing is
10.
Yeah, very good. Okay, so now we know 4, 10, and 4. We're finding the perimeter. So now I'm done with all these parts, but now I got to find the perimeter of that. I need to put my dotted line better. Whoops. Okay, whatever. Okay, so how am I going to find this, the perimeter? That's the circumference, right?
Yeah.
Because the circumference of a circle is the outside of a circle, the distance.
Mm-hmm.
But circumference equals what as a formula? Pi.
Yeah, pi r squared.
No, that's area.
Pi d.
Pi d. Okay? And because we're wanting to do not a whole circle, we're wanting to do a
Diameter is 10, right?
diameter is 10. Very good. Okay? But because we're finding... Okay, so, sorry about that. Let's look back at this. So, the circumference of a circle, a normal circle around, is pi times diameter. But this is not a whole circle, it is a
half circle.
Half circle. So, for a semicircle, that's what it is. Okay, so what is pi? Pi is 3.14 times, what is our diameter?
10.
5 and 5, 10. Okay, and then that's divided by 2. Okay? And 3.14 times 10 is going to be 31.4 divided by 2, which is going to be, I'm just going to go and look, 15.7. Okay? So this thing right here on the outside measuring it is 15.7. Okay? Now, to find the perimeter of all of this, we add 15.7 plus 4 plus 10 plus 4. And that equals 33.7 meters or whatever it was. Okay? Feel like you understand it? Alright, let's do another one. Now this next one looks the same, but I want you to pay attention to it. Okay? Beautiful. Okay? I want you to pay attention to it because, again, we have 5 and 4 up there. Alright, and here's what it says. Find the area of this figure. Okay.
So it's going to be 10 again.
Yes, this is going to be 10.
That's going to be 4.
And that's a 4. Well, we don't need that because area is the inside.
Okay.
So area means we're going to find the area of this rectangle. So area of the rectangle, AR. And then we're going to find the area of a circle. And then I'm going to put divided by 2 to show myself it's a circle divided by 2. It's a semicircle. Okay. So the area of a rectangle is what times what? Length times width, right? Length times width, which would be what in this problem?
What? Length times width? That's 10 times 4.
Very good, which is 40, and this is meters? Meters. 40 meters squared, and squared because we're doing area. Alright, now let's look at this one. What about this one, Elon? Area of a circle divided by 2. What is the area of a circle formula?
Circumference.
No, that's the area, that's circumference.
Pi r squared
Pi
divided
r
by 2.
Squared, and because it's a semicircle divided by 2. Very good. Okay, pi is 3.14 times, what is our radius?
5.
5 squared, which is 25. And then we're going to divide that all by 2. So, 3.14 times 25 divided by 2 is 39.25. Okay? But are we done? No. Because I found the area of this triangle, and I found the, rectangle, and I found the area of this semicircle, but now I have to combine them. Okay? So this 40 plus this 39.25 is going to be 79.25, and this is meters squared because we're working with area.
So that's the answer.
Got it? We add those two. This one, the area of this plus the area of this. Got it?
Mm-hmm.
All right. We've got a few more problems. All right? Each of them's different, so you have to really pay attention. This next one is a circle. Now, I don't know if I've told you this or not before, but the degrees from the top of a circle all the way around to the other side is, do you remember?
360.
Yes, very good. So that is good to know, that to do a full circle, it's 360 degrees. That's very important to know. Now, here's what they say. They've got this little piece cut out right here. And then they tell me from here to here is 6 centimeters. And then the other information they give me is they're taking this whole thing and it is 300 degrees. Okay, so the distance from this angle all the way around is 300 degrees. So what does that tell me this piece is? 60 degrees. Now, knowing that, stay with me, how many pieces of this do we have around this whole thing?
We could divide it by...
You're going to take 360, and I'm going to divide it into that many pieces, 60.
Like 60.
And so, 60 times 6 is 360. So there are literally 6 of these.
Yeah.
Okay, 1, 2, 3, 4, 5, 6. Okay, whatever. I don't know if I did it right. Anyway, so that's 60 degrees. So there are 6 of them. You with me? Mm-hmm. Now, knowing that, that was good information for us to know. Now, Listen to the problem. Find the area of the shaded sector.
Okay.
Did I do 7? Yeah, anyway, just pretend like it's 6. Okay, 1, 2, 3, 4, 5, 6. There are 7. Okay, boy. Anyway, just pretend like there are 6. There we go. I'll just leave them off. There we go. Now, they want us to find the area of this. That's it. Okay.
Just that one piece.
How do I find the area of this piece? Well, area is pi r squared.
Do we know the radius?
Yes?
Yeah, what is it?
6
Oh,
centimeters? Yeah. Okay? So, we know what pi is. We know what the radius is. Okay? But when we had a semicircle, we divided it by 2.
Mm-hmm.
What kind of thing is this?
36 is the diameter. Oh, I mean, radius squared.
6 times 6. The radius is 6, so 6 times 6 is 36. Very good.
And then 3.14 times that divided by 2.
3.14 almost times 36. 3.14 times 6. Okay, let's just do it quick. 8, 10, 12, 4, 9, 4, 0. Okay, 113.04 is the area of the full circle. But how much of a piece is this?
So then we divide it by 6.
Very good. Then you take this and divide it by 6. Good job. Because there are 6 of these pieces, remember? Alright, and this is just one of them. So if it was half, we'd divide it by 2. But because it's a 1/6 of the pi, or the piece, circle, then it's this. Okay? And when we figured this out, 6 goes into this, 18.84. And because we're working with area, it's going to be squared. Got it? Feel like you understand it?
Mm-hmm.
Alright. The last part of the lesson is pretty easy, but it shifts gears. Alright? You're going to learn about a minor arc and a major arc. And it's exactly what that is. Something big and something small. Minor and major. So for example, let me draw a circle up here, and I have A, B, and C. So if I said, starting at A and going clockwise, okay, from here to here, is it a minor or a major arc? Well, it's considered minor if it is less than a semicircle. So a semicircle is half. So, is this arc AB minor or major?
Minor?
Minor, because it's less than a semicircle. A semicircle would be right here. Okay? So, is A, B, C a minor or a major arc?
Major.
Major, because it's greater than a semicircle. Do you understand what I mean by that? Mm-hmm. It goes past that. Alright? What if I told you to go counterclockwise? Is AC minor or major?
Minor.
And ACB?
Major.
Very good. Okay? That's pretty much what you're learning. Alright? We're almost done. You hanging in?
Mm-hmm.
Alright, look at this figure. You'll like these because this is geometry stuff.
Okay.
Okay, A, O, and C. And then here's a D. Okay, here's what it says. In this figure, central angle AOC measures 70 degrees. What is the measure of major arc ADC? ADC. So pretty much
that's major.
all of that.
That's what you're asking.
Yep. So if this is 70, what is ADC, which is really from this spot to this spot? Because that's the C. You see? Mm-hmm. Do you see? Okay, so it goes from here, the A, all the way around to the C. So what is this going to be? How am I going to figure that out? How many degrees is it? Well, how much is a full circle?
360.
Okay? And
That's 70.
we're taking off how much of
So
the
that's
circle?
so it's 90, right?
Yep. So it'd be 290 when you
Yeah.
subtract 70 from it. Okay? So this whole thing right here measures 290 degrees. Okay?
Mm-hmm.
Alright, last problem. And we're done. Okay, I'm going to draw a little. Alright, so stay with me. Obviously, 1, 2, 1, 2, 1, 2. A minor arc with a radius of 2 centered at the origin is drawn from the positive x-axis to the positive y-axis. So from the positive x-axis to the positive y-axis. You see that?
Mm-hmm.
It's this angle right here. So it would be like if this was a full circle. But we're not doing the full circle, we're just doing this portion.
Mm-hmm.
Alright, it says, what is the length of the arc? Okay? What is the length of the arc? Length is distance.
Yeah.
And what is distance when you're going around a circle?
What do you mean?
What's the distance?
360?
Distance, what is the formula? Circumference. Circumference equals, the formula
Pi
is
d.
pi d. Okay, but are we figuring out the full circle?
No.
No. How much of the circle are we figuring out?
1/4.
A fourth of it. So, we're going to find the circumference, pi times d, divided by 4. Very good. Now, they told us that the radius was 2. 1, 2. Okay? So, pi times, what's my diameter?
2.
No, that's radius.
Oh, sorry. 4.
4. So, pi times 4 divided by 4.
Mm-hmm.
Right?
3.4.
Pretty much those cancel, so the final answer would be 3.14. Isn't that cool that we can do that? Alright, that's lesson 104.